So the last bit of information and analysis of a velocity time graph is using it to be able to find displacements, which is possible. Let me give you the simplest example for the theory, and then we'll go into a little more complicated analysis, complicated examples, complicated portions. Let's look at just this little section of the graph in red. And notice that we have 5 units of velocity. We have 1 unit of time. And if we look at the formula, velocity average equals change in distance over change in time. And if we rearrange this and we simplify it and put the t on the other side, so delta t times velocity average equals delta x. So what I did was I multiplied each side by delta t. I got rid of the delta t on this side. I had delta t over here. So change in displacement is equal to your time times your velocity. And if you look at that, that's what you're really doing here. Your 0 to 5 is your velocity, and your 0 to 1 is your time. And if you multiply those two together, it ends up giving you, just mathematically, or geometrically, it gives you an area. And so if I multiply 5 times 1, that means that this little section here, I traveled 5.0 meters. And that makes sense, because if I were to plug this algebraically into this equation, if I knew that, I'll do this over here. If I knew the average velocity was 5.0, because it didn't change, it was staying 5.0. And I happen to know I did this for 1.0 seconds, well, I can solve that for x. It would end up being 5. So that theory of finding the geometric area under the curve from a velocity time graph allows us to find displacement during that time frame. So for the first second, I moved 5 meters. Now, if I wanted to find the total displacement from 0 to 4 seconds, that means I would have to find the area of all of this under, they say under the curve, from under the blue line to the time axis. And this is a little bit of a pain because of the shape that I use, but I can see that if I split this up, and I've already did a little pre-plotting on this so that you can, so that we can handle this a little bit better. So I happened to do a little pre-plotting earlier, and I know this worked. This worked. So you really got to break this up into some dumb shapes. This worked, and this worked. Yeah, it's kind of dumb, but I was trying to find the shapes that are going to match better and break it up. So you have all these little areas, and you can find the areas and add them up. So for this area, you have 5 times 1, 2, I'm sorry, 5 times 2. I expanded this. So 5 times 2. So for this area here, that's worth 5 times 2 is 10 meters. Now, this area here is a triangle. And so that area is 1/2 base times height. So 1 times 15 times half. So 1 times 15 times half is 7.5. This little area here. So we have a rectangle 1 times 10, which is another area of 10.0. And then we have 2 triangles here, and they're both similar triangles, or identical triangles actually. They have heights of 10 and bases of 1. So 1/2 base times height, so 10 times 1 times a half is 5, and 5. Now, a lot of the problems we're going to get are going to be simpler in terms of finding the area under the curve. But if I go and add all these areas up, total distance traveled from 0 to 4 seconds would be 10, 20, 37.5 meters. Now, the problem doesn't have to ask you nicely from 0 to 4. The problem could ask you something like, how far did you go from 2 to 4? And then you just take these areas and you wouldn't include these areas. Or the problem could say, well, what about from 0 to 5 seconds? And that creates a bit of an issue, because when you're over here at 5 seconds, you don't have area under the curve, but you do, because this line continues, and you can go to 5, and so you do have this other little triangle. And you can find that area of that triangle. 1 times 10, 10, but it's a triangle, so 1/2 base times 10. So this area is worth 5. But what you need to know is if the area is under the t-axis, this is considered negative area. So I got this 4.0 in the way. I'm going to get rid of it a little bit. So this is actually an area worth minus 5. So any areas under the t-axis are negative, because you're traveling backwards. You're going back the way you came. So you went so far, now you're traveling back. So your displacement is now less from the place you started, because you're moving back towards it. So if I wanted from 0 to 5 seconds, it wouldn't be 37.5. From 0 to 5 seconds, it'll be 37.5 minus the 5, 32.5 meters. And in both of those cases, that would be your displacement for those time frames. Area under the curve is a big theme in this class, not only for velocity time graphs, but in other areas and other analysis, which we'll get to later in the year. You will not do any area under the curve for a distance time graph. That doesn't mean anything, okay? All right, lot to process.